All right, question 58. From the graph, identify the domain and range in interval notation. Now, this graph may be slightly different than the one you might be looking at on your review. I've improved the graph, although it is very, very similar. I think this is more what was intended when the other graph was drawn. So if you don't see this graph that looks exactly like this, maybe yours is red, just know that the intention of that graph is what this graph is. So when we're identifying the domain, okay, domain here, and then range in interval notation, we want to, again, look at domain as being left to right. So these are your x coordinates and range is your y coordinates, right? So for the domain, we are going from left to right. So looking at my graph here, I see that if I follow, I see the arrow is pointing down and to the left, and it's kind of slanted outward. So that means it's going to go forever to the left this way, right? And if I just kind of follow along my graph, I see I have points at all of these spots until I get here. And then right here, this is where my graph stops. And I have a solid filled in circle right there. So I'm going to go ahead and put a bracket on that. And remember that this does go out to negative infinity, right? Because you're going to the left on the graph or on a number line. So this would be a negative infinity. So when we read it from left to right, we're going to put a parentheses on negative infinity. And then the farthest right that it goes is to where x is equal to 2. And we put a bracket there. Okay, now for the range, this is going to be from bottom to top. Okay, so we're going to do a, looking at that arrows pointing forever down. And then if I just follow this all the way up to the highest point. Now don't stop here. That's not the highest point, right? The highest point is all the way up here at 4. Okay, so where x is equal to, the y coordinate is equal to 4. This is where the graph goes, right there. So we're going to put a bracket there, okay? And we know that at the bottom, oops, didn't mean to do that. At the bottom, this is also negative infinity, right? So going from bottom to top, the lowest point, negative infinity, to the highest point is going to be positive 4 with a bracket there. Okay, so we're going to, let me just, range, domain, okay. And we will box that there and then box this here. All right. Write the given numbers from least to greatest. Okay, so we want to really make sure they're all in an equivalent form. So some of these numbers are in percent form, some in decimal form, some in fraction form. And so in order to evenly compare them, we want them all to be in the same format. And the easiest one to look at would be decimal form. So I'm going to go ahead and take that negative 1/7. I'm going to divide that, and I'm going to get here, let me write this over here. Negative 1/7 is equal to approximately, let me do approximately equal to negative 0.14, I'll say 29, okay? And then we have 2.5, which is already in decimal form. We have 9, which is already in decimal form. But we have 6.2%. And remember that percent means per 100. So if I put 6.2 divided by, that means per 100, this is going to be equal to 0.062. So now these are written in equivalent formats. So we've got your negative 1/7 here, and then you've got your 6.2% here. So I'm just going to go ahead and write underneath these numbers what exactly they're equal to in the decimal form. We have negative 0.1429. That's that one. We have 2.5. Then we have 9. 0.062. Okay, so that's this one. That one's this one. Okay. Now we can look at them and put them in order. So in order. Okay, what do we have? Well, obviously negatives are going to be the smallest. So -1/7 should go first. Then it looks like 0.062 is going to be small. The next one, so we're going to put that here, 6.2%. Then 2.5, and then 9 is your biggest. So that's all of them in order. Okay. All right, 60 to 63 says just to simplify. All right, so in order to simplify fractions, we need to find least common denominator. I say simplify, I mean like add and subtract fractions. We need to find a least common denominator. So looking at 4, 14, and 7, I need to find an LCD. So LCD. So I'm going to just write 4 is equal to 2 times 2. 14 is equal to 2 times 7. And 7, well, 7 is just 7. Okay, so what we need to do is we need to take each of these columns, right? And I'm going to bring them down. So I've got a 2, another 2, and then a 7. And I'm going to multiply all of those numbers together. So 2 times 2 times 7. And this is going to equal my LCD. Okay, so LCD is 28. Okay, so let me bring all of those down. There we go. Okay, so now I've got 28 as my least common denominator, so I just need to rewrite all of those. Here we go. Actually, let me do this. Can I erase this and move this up? Here. Right there. Okay. So I need to rewrite all of these fractions with that same denominator. So I need to multiply 3 over 4 by 7 over 7. So negative, here we go. I'll just do it this way. I'm going to put all their signs here. So this one, we have to multiply all of these, right? So we're going to multiply this one here by 7 over 7. 14, we're going to multiply by 2 over 2. And then 7, we're going to multiply by 4 over 4, right? Okay. So let's see what we get. Negative 21 over 28. Negative 2 over 28. And a positive 24 over 28. Well, now we just need to combine the top numbers, right? We have negative 21 minus 2 plus 24. And that's going to, 1. It gives me 1. I guess it does. 1 over 28. Okay. Now you might be asking yourself, why did we even bother doing all of this by hand when we could just type it in the calculator? I mean, sure you can, but I'm just showing you this is how you would do it if you did not have a calculator. Fun facts, you might notice that the missing thing right here from all of these, this is the 7, right? From the 4. Oh, look at that. There's the 7 right there. And then from the 14, the missing thing was a 2 right here. Oh, look at that. There's a 2 right there. And then the missing thing from the 7 was 2 2s right here. In other words, 2 times 2, which is 4 right there and there. Ah, fun facts. So anyways, this is how you would, yes, do that by hand. All right. Next one, number 61. We have 6/12 plus 7/18. So we need to find the LCD. Now, I offhand just noticed that 6/12 can be reduced. So I don't know that do we need to reduce it at the beginning, or should we just go from here? I don't know. It's up to you, right? But I'm going to go ahead and just find the LCD here. So 12 is equal to 2 times 2 times 3. Right? That's 4 times 3. And then 18 is equal to 2 times 3 times 3. And you'll notice that when I line them up, I make sure I always line them up with numbers that are the same. And if they don't have numbers that are the same, I put them in a separate column. So like here I've got 2, 2, 3, and 3. So 2 times 2 times 3 times 3. This is going to be the LCD. So 4 times 9 is, what is that, 36? I think it is. Yeah, 36. Okay, so 6/12 and then 7/18, both positive, right? So this one we're going to multiply by 3/3. And then this one we're going to multiply by 2/2. So we get 18/36 and 14/36. So when we combine those, 18 plus 14 equals 32/36. Okay, now we do need to reduce that, right? So 32 and 36 do have a common factor of at least 2, but maybe I can divide them by something bigger. Maybe 4, maybe more. I don't know. Let's 32 divided by 36. Math, enter, enter. Oh, 8/9. So this reduces to 8/9. Okay. Yeah, so 4 times 8 over 4 times 9. And then you can cancel out your 4s. Right. Okay, moving on. What do we have next? Oh, multiplication. So multiplying is pretty easy, pretty straightforward. Multiply straight across. This is what we want to do. 2 times 3 is 6, and 7 times 6 is 42. And then, of course, reduce at the end. So if 6 can be written as 1 times 6, and 42 can be written as 7 times 6, then we can cancel out the 6's, and we're left with 1/7. Now, you can reduce earlier if you want to. You can simplify any numerator with any denominator. Up to you. I think a lot of times most students prefer to wait and do it at the very end. So there you go. All right. Now, when you divide fractions, though, you need to do the keep, change, flip, right? So keep the first one, change to multiplication, flip the second one, and then you do the same as what you just did on number 62, straight across. 5 times 7 is 35, and 8 times 3 is 24. And I don't know that those numbers have anything in common. 35 divided by 24. Nope, doesn't look like it. Now, you can obviously tell looking at the numbers as they are initially. I mean, 5 has nothing in common with 8 and 3. 7 has nothing in common with 8 and 3. And therefore, this would be fully simplified at the end, right? So, yeah, there we go. All right, number 64. For the graph, state the coordinates of the intercepts. So that means x and y intercepts. So for the x-intercept and the y-intercept, we want to write the ordered pair, always as a point. Okay, so let's see here. For the x-intercept, I'm looking at where does the graph cross the x-axis. So the x-axis is here, and it looks like it's crossing where the x-coordinate is a 3. So this is going to be 3, 0. And then for the y-intercept, it looks like it's crossing here where the y-coordinate is a 1. So 0, 1. And let me just highlight my y-intercept here in orange. I need a darker blue. Is that the dark blue that I have? Maybe that one. This may be too dark. Oh, I think I already added it. Oops, I added it twice. Is that the same? It looks purpley. That's fine. You guys get the idea. Okay, x-intercept. State the slope. Okay, well, now that we know the x and y intercepts, we can easily count slope, rise over run. Remember that slope is rise over run. So pick any point on your graph at an integer value and then count how many you go up or down to get to the other one, and then how many go left or right. So if I'm following here, I'm going to go down 1 and to the right 1, 2, 3. So my down is -1, and then to the right is going to be +3. Okay, so down 1, -1, and then run +3. So your slope is -1/3. Okay, identify the domain and range. Okay, in interval notation. So your domain, this one, range, this one. Okay, so if you're looking at your graph here, because it's a slanted line, the domain and range are both going to be -infinity to infinity, because looking at your graph here, it goes forever to the left. Oops, let me do the skinny one. It goes forever to the left and forever to the right. So your domain is going to be -infinity to infinity. And your range, same thing, right? It goes forever down, and then it goes forever up because of the arrows on both sides. So domain and range happen to both be -infinity to infinity, infinity, the same. So domain, -infinity to infinity, range, -infinity to infinity. There we go. All right. Moving on. Find the slope of the line passing through these 2 points. Okay, so what you'll need here is a formula. Slope formula, y2 minus y1 over x2 minus x1. So this is a formula you will need to know. I'm going to just, oh, let me not do that. Let's go this. Okay. So this formula must know. And here we go. We're going to go, let's label these. x1, y1. x2, y2. Now, it doesn't matter which one you make, x1 and y1 and x2 and y2. What matters is that you make 1 point your point 1 and 1 point 2. So maybe let's make this point 1 and this point 2. But if you want to switch them and make the first one point 2 and the second one point 1, that's totally fine. And then you want to make sure that your x and y for each of those aligns with the subscript 1 and 1, right? And this is your x and y coordinate. That's 2 and 2, right? So they have to come from the same ordered pair. So in our case, we are going to do y2 as 2. And then y1 is going to be -1. Then we have x2, which is 4, and x1, which is 3. Now, you'll notice that when I substituted everything in, I made sure that anything coming after a minus sign is put in parentheses. I highly, highly recommend always doing that so that you don't accidentally combine your negative signs. So, like, here, this is your y1, right? There's that guy right there. It's coming after that minus sign, and you do not want to accidentally combine it with, you don't want to make that as just 2 minus 1, which a lot of people end up doing because they don't use parentheses. See, this is your y2, and then this is your x2. Okay, see how those colors are kind of together, lined up above each other? Okay. All right, so we have 2 plus 1, because minus negative, and then 4 minus 3. So now we get 3 over 1, or 3. So we would just say that m equals 3. If you're going to actually graph it, I would leave it over 1. But if you're not graphing it, just write it as 3. Okay, write the equation of the line with slope m equals 5 that contains the point -2, -4 in slope-intercept form. Couple formulas you need for this. You're going to need the point slope formula. That's this one here. And you're going to need to know y equals mx plus b because that's what you have to write your equation in afterwards. So both of those formulas important here. I'll just highlight those. All right. And I'll call this is point slope, and this is slope intercept. Okay. So now we have been given, I'm going to just kind of divide this out here. So we've been given a slope of 5, and then our point here is -2, -4, okay? So we're going to substitute this into our formula. Y minus y1 equals m times x minus x1. And I'm going to color code some things here. Okay, so we used this on x1 right here, x1. Okay, and then we used this on y1. And then we will use, what color did I not use? Red, I guess. We'll use that for the slope. There we go. Okay, so when we substitute things in, y minus, put in parentheses here, -4, equals 5 times x minus, put in parentheses, -2. Okay, because again, same thing, you just don't want to end up with putting your, let's see, you don't want to combine a minus and a negative sign, okay? Oh, I didn't use purple. Maybe I should have used purple instead of red. It's fine. It's fine. Okay, minus -4 becomes y plus 4. And then minus -2 becomes x plus 2. Okay, and now we need to put it in the slope-intercept form. So we'll need to distribute the 5, and then we will subtract the 4x over. So I'm going to go ahead and come up here and rewrite this. Y plus 4 equals 5 times x plus 2. So we're going to distribute. We have y plus 4 equals 5x plus 10. Okay? Now we're going to subtract 4 on both sides. Y equals 5x plus 6. 10 minus 4 is 6. There we go. Okay. Determine if the lines y minus 4/7 x equals 3 and 4y equals -7x plus 28 are perpendicular, parallel, or neither. Okay, in order to know if lines are parallel, perpendicular, or neither, we must know a couple of things. In order for lines to be parallel, they must have same slope, but different y-intercepts, okay? And then let me see how I want to just, maybe I don't want to write it quite like that. Let's see here. Same slope, different y-intercepts, okay? And then to be perpendicular, the slopes have to be opposite reciprocals of each other. Must be opposite reciprocals. That means one has to be positive, one has to be negative, and then reciprocals are a fraction like flipped, okay? So that's the things you need to know. Okay, so let's figure out the slopes. That's really the most important thing. We have to compare slopes for both. So we'll start with our first equation, y minus 4/7 x equals 3. And then we have 4y equals -7x plus 28. Okay, so for this first one, I'm going to put it in slope-intercept form by adding 4/7 x to both sides. So y equals 4/7 x plus 3. So my slope here is 4/7, okay? Now my y-intercept is plus 3. I'm just going to leave that alone for now. All right, now I'm going to look at my other equation. I need to divide everything by 4 to get y by itself. So y equals negative 7 over 4x plus 28 divided by 4, 7. Okay, so my slope here is negative 7 over 4. So we need to compare our slopes, okay? So let's see here. We've got this slope, positive 4 over 7. And we have this slope, negative 7 over 4. So already I can see these are not the same, right? These are not the same number. So therefore, this is not parallel, okay? So, I mean, make a note here, not parallel. Okay. Next, are they perpendicular? So do they have opposite signs, one positive, one negative? The answer is yes, check. All right. So actually, y'all, I know. I'm sorry. I'm so sorry. Let me do this. Are the slopes the same? If yes, well, you need to check the y-intercepts. But, right, if the slopes are the same and the y-intercepts are different, then parallel. If no, go to number 2. Opposite signs. If yes, are they reciprocals? If no, neither, right? So, y'all, I just really don't have the best way to do this. I'm sorry. But I'm giving you all the information, so however you want to write this. Are they opposite signs? If yes, are they reciprocals? If yes, perpendicular. If no to any of these things, then these would be neither. So we have opposite signs, yes. Reciprocals, yes. These are perpendicular. I don't know. I'm sorry. I've got nothing. Okay, let's try it. Okay, slopes not the same, so not parallel. Slopes are opposite, reciprocals. So they are perpendicular. I guess I'll go with that. There we go. All right. Okay. My apologies for the time wasting here. Okay, 68 and 69, simplify and express using positive exponents. Okay, so 68 has a product of things raised to the same power. So in that case, product to a power, you need to take everything in the parentheses and raise it to that power. So negative 2 has to be raised to the negative third power. X to the third needs to be to the negative third power. And y to the negative fourth has to go to the negative third power. Now, when you have a power to a power, you would multiply your exponents. Now, I would like to point out that negative 2 here has an exponent of 1. Okay, so when we say power to a power, the exponent on the inside is a 1. Okay, it's not negative 2. You don't multiply, you never multiply an exponent times a base, okay? So you only ever multiply your exponents together. So in this case, we're going to multiply these two things here, and these two things here, and these two things here, okay? So negative 2 is going to be 1 times negative 3 is negative 3, okay? Keep it like that. 3 times negative 3 is going to be x to the negative 9th. And then -4 times -3 is going to be a positive 12. Okay. Now, anything that has a negative exponent needs to be rewritten with a positive exponent. So, in order to do that, we move to the bottom side of the fraction bar. Anything with a positive exponent stays where it's at. So right now, the y has a positive exponent. So we're going to leave that on the top of the fraction. And on the bottom, we're going to put -2 to the positive third and x to the positive ninth. Now, if we can figure out -2 to the positive third power, we can go ahead and calculate that value. So let's do that. Parentheses, -2, close parentheses, to the power of 3 gives us a -8. So y to the 12th over -8, x to the ninth. This would be our final answer here. Okay. Now on 72, we're first looking to see we have two separate things here. We have numbers and then we have p's. So we could write this as 21 over 28 to reduce. And then we can put p to the -4 over p to the 9. And we can simplify that kind of separate, right? Simplify them separately. So 21 over 28 can be reduced by putting 3 times 7 over 4 times 7. And we can cancel out the 7s, okay? And then when we're looking at the p's, we have a couple options. We can just subtract, where we get p to the -4 minus 9, and then deal with it at the end, or we can make everything positive and then deal with things there, up to you. But usually I just take the top exponent minus the bottom one, and then I'll deal with the aftermath. So -4 minus 9 is -13. So this is what I have. I have 3/4, and then I have p to the -13 right now. Now I need to make that a positive exponent. So I'm going to leave the 3 on the top, and I'm going to put 4 on the bottom, and p to the positive 13 down here. So now this would be my final answer to make it look clean. Okay. Number 70. Solve the system of equations by substitution method. So we need to choose one equation to solve for one variable, and then we're going to substitute it into the other equation. So let me put a 1 here and a 2 here. I'm going to solve equation 1 for x. Seems the easiest. Now, this is how I choose. I'm looking at all of my variables, y, x, x, y, and I'm saying which one has a coefficient of 1. So, in other words, the number in front. This is a 5, this is a 2, this is a 10. This one has a 1 in front. So that's why I choose this one to solve. Okay, that's going to be the easiest one. It avoids fractions. So we have 5y equals x plus 12. I'm going to subtract the 12 on both sides so that we have x equals 5y minus 12. Okay. Now I went ahead and switched sides there as well. I kind of did two things at once. When I subtracted the 12 over, I just moved the x over here on the left. Maybe that would, I don't want to be confusing. Let me write it. I'll do 2 steps. There we go. Okay. All right. Now then, we're going to take that and we're going to plug that into the other equation. So we're going to substitute into equation 2, this right here. Okay. So sub into 2. All right. So equation 2, this is it. 2x minus 10y equals 5. I'm going to be replacing the x here with what I have right there. So 2 times 5y minus 12 minus 10y equals 5. So this is the replacement. Okay. So distribute. 2 times 5 is 10y minus 24 minus 10y equals 5. Okay, when I rearrange it, 10y minus 10y minus 24 equals 5. I see that I have these guys right here. Okay. So when I rearrange it, 10y minus 10y actually, that adds up to 0, right? So now what do I have? I have negative 24 equals 5, which is false. Okay, so if that happens, your variables cancel out and you have a false statement, that means there is no solution. Okay, remember that what we are looking for here is we're looking for the point where the lines cross, the point of intersection. And if there is no solution, what that tells me is that these lines are parallel because they never intersect anywhere. All right, I think that might be a good stopping